Welcome back to Incremental, the continuous improvement podcast. I'm Devin Bedoni. This is our concepts edition for the week.
And I'm Uriel Eisen, and this week we're going to be going over SMED, which is single minute exchange of dyes, a super key aspect of lean in manufacturing and the total production system in manufacturing, but also extended to other things.
Yeah, and I think even if you're not doing lean, quote unquote, this is still something to pay attention to regardless. Super key.
Definitely my introduction to Shigeo Shingo, and I found his way of thinking to be very interesting and inspiring and analytical in a very cool way.
And I think like once you start tackling this, it feeds straight into all the other kind of aspects that we've been talking about of like standardization, documentation, all of those things flow out of trying to apply this concept. So it seems like you can almost like throw the rest of everything out a little bit and just start with this, and like the rest of it will come as necessary in a certain sense.
Yeah, I would say this was like the first book I read. This was sort of, I feel like, the beginning of actually successfully implementing lean and TPS and continuous improvement in the shop. Was just like reading this. It was very inspiring.
Yeah.
And then also we just immediately cut our setup times in half without spending any money, or really, like, it was probably like 20 minutes.
Yeah.
Anyway, we'll get to how it's sort of applied. But this is the introduction instead of a quote for the week. This is Shigeo writing. When I ask about the major difficulties encountered in many factories I visit, the response is usually brief: diversified low-volume production. When I dig a little deeper and inquire why diversified low-volume production constitutes a problem, the main difficulty generally turns out to be setup operations required. Calibration, switching of tools or dies, etc. Frequent setups are necessary to produce a variety of goods in small lots.
Yeah.
So, I think, one thing we've talked a lot about is this book was definitely written about manufacturing facilities, but it turns out that behind all batch work is basically long setup times. And the second you get rid of the setup time, there's really no temptation to batch. And it might not be setup time exactly. It could also be, which is part of setup time. It could be transportation, like if you have to write an email and your desk is...
Which he tackles as part of setup operations.
Yeah, as transportation.
Yeah.
Like if your desk is really far away from where you do your work, there's going to be a temptation to go to your desk and do a lot of work.
Yeah.
Right? Like if your computer is at home, for example, or something, right?
Yeah. And just to hit you guys with a couple bangers that really drive it home. There's examples like, so the book that we are both looking at right now is called A Revolution in Manufacturing, the SMED system. There's examples all through it of like incredible reductions in setup times and increases in efficiency.
Credible reductions.
But two bangers. At Toyota Motor Company, the internal setup time of a bolt maker, I'm assuming that's a lathe or some, maybe a roll former or something, which had previously required 8 hours, was cut to 58 seconds. And at Mitsubishi Heavy Industries, the internal setup time for a 6-arbor boring machine, which had previously required 24 hours, was reduced to 2 minutes and 40 seconds.
Yeah, pretty powerful stuff.
Yeah.
It also strikes me, I'm thinking about it now, a lot of the tools used in this book are pretty simple and key in very nicely to theory of constraints. What does he call it? Maximizing the bottleneck.
Right.
Like this is
exploit
the bottleneck. Yeah. This is a great way to do it.
Right. Yeah. And a lot of these examples are obviously oriented towards repeat production. So not necessarily custom work every time, but I do think most of the principles still apply. Because it turns out that we do most of the same things every day, just with very, very slight variations.
I mean, this is why like tool changers are very popular in CNC shops, right? They didn't used to exist.
Exactly.
Reducing setup time to change tools.
Yeah.
A little history of SMED. So in the 1950s, I want to say, Toyota found out that Volkswagen was setting up their 800,000 ton presses in 2 hours, and at Toyota it was taking them 4 hours. And this is after a lot of work where it would take like a day.
Yeah.
But it was taking them 4 hours. They discovered Volkswagen was doing it in 2 hours. They brought Shigeo Shingo in to help get the time down. And after, I think it was 6 months of work, they got it down to 90 minutes, which was a huge reduction. And then after some brilliant insights and light bulb moments, and another 3 months of work, they got it down, I believe, to 3 minutes from 4 hours. And there's a few quotes in this book from Ono, and who ran Toyota, about the importance of reducing setup times for just-in-time manufacturing and the Toyota production system, like how essential it is for the rest of it. It's all sort of predicated on this to make it financially viable. Anyway, so in doing that, from going for 4 hours to 3 minutes, there was just a series of steps that are actually not very complicated. It seems like to get such mind-blowing results, there would need to be some like huge insights, but I would say
magic.
And I feel like a common theme is actually simplicity and just like really good thinking and like questioning. There's a chapter in this book which I got a real kick out of, which was like how to like using screws and fasteners better. And the reason it's in this book is because most people don't do it.
Right.
And after reading that, I looked at our Vice and I was like, he says like, don't put more screws than you need. Analyze the forces and get rid of fasteners you don't need as step one of this fastener chapter. And we had 4 bolts holding down each set of jaws. And I was like, we only need 2. And so now that cut our bolting time in half.
I think like as with many things in this whole journey, whatever we want to call it, a lot of the real magic is just in kind of the analysis tools. And so I went back to the book last night and I kind of thought that the very beginning was really, really key. And, he kind of, again, breaks things down into processes and operations, which we've talked about in the past. But then he breaks down operations more specifically. And I think that's kind of where you enter into the SMED world. And so I'm just going to read a couple of those, or kind of read his breakdown. Which is the internal structure of an operation can be analyzed as follows, which is preparation and after adjustment. And these are things that are performed once before and after each lot is processed. And in this book, they are referred to as setup operations. Principal operations carried out for each item. These operations fall into 3 categories. So he's breaking it down into 2 broad, and then principal is breaking down into 3. Which is essential operations, the actual machining, manufacturing, processing of the material. Auxiliary operations, attaching work pieces to or removing them from machines. And margin allowances, which are irregularly occurring actions such as resting, drinking water, sweeping, machinery breakdown, fatigue, hygiene, operation, which and then shop-wide or specific. And I think this seems so simple, but what's really powerful here is most of us, I think, generally for most of our careers, don't do this very first basic step in looking at our processes. We're just kind of like, this is the stuff we have to do to make stuff. So we'll just keep doing it. And this key thing of like analyzing your actual operation and being like, okay, what is, in the Toyota term, value add? sort of like we're actually changing the shape of some stuff, or we're, you know, adding like engineering value to an idea. And what is the rest of it is just like moving stuff from place to place essentially, or cleaning, or whatever the case may be. So I thought that was like a really key. You can almost just start with that, and just like you could spend a month just going around your shop, just sort of analyzing, and that would lead you down a lot of, I think, really good paths.
Yeah.
And then he does another little breakdown here that I had marked out. So he's breaking down manufacturing into work, inspection, transportation, and storage. Each has a corresponding operation. That is, there are work operations, inspection operations, transportation operations, and storage operations. And of these, each of these operations has 4 subcategories: setup, essential, auxiliary, and margin allowance. And so you're kind of breaking down each operation by what's essential, what is auxiliary, etc., and then kind of breaking down your whole process based on what is work, inspection, transportation, etc. And you can just follow that path to weed out a lot of the unnecessary work that's being done.
Yeah, I think, so those are sort of the broad analysis, and then the steps that are specific to SMED, he breaks it down into 4 stages.
Mm-hmm.
The first stage is operations are not internal. He distinguishes between internal setup times and external setup times, which is, I don't know why internal and external. It's to the machine essentially, but basically,
I think it's simply things that can be done outside the process versus things that have to be done while the process is stopped.
So, for example, on a milling machine, or to go back to our favorite kitchen example, in a dishwasher, house dishwashers have no ability to do external setups, meaning you need to stop the dishwasher to open it up to unload and reload, whereas commercial dishwashers, you have a bunch of extra racks, so while the machine is running, you can be loading the next rack. And so you've converted internal setup times and made them external. And so the initial stage is basically non-distinguished internal versus external activities. And so that's where most shops exist to this day, is just existing in a state of, like you were saying, these are all the things that need to get done. Now that the machine is stopped, let's do them all. And then step 1 is actually just explicitly differentiating between internal and external. So that would be... so I'll give a specific example. For us, we went from a 14-minute setup time down to a 7-minute setup time just by doing this step, which is literally just spending 10 minutes to look at all the operations required for setting up a new part and saying, does this need to happen with the machine stopped, or can we do it before?
Because most of us tend to just be like, okay, it's setup time now. This thing stopped. Now it's time to set up for the next. Let's do all the things involved in setup.
So
instead
for example,
of realizing that a lot of that can happen prior.
For us, the initial stage, which is non-distinguished, was basically the machine stops. We open the doors. We would unbolt the jaws from the vise. We would then get the new jaws for the next part. We'd blow off the new jaws. We'd blow off the vise. We'd put the jaws on. Well, blowing off the new jaws could happen before the machine stopped. So now we're blowing off the jaws and staging them before the machine stops. Moving parts closer to the machine for that next setup. That's all stuff that can be done beforehand. Other examples, trying to think. So we'd stage everything. We'd make sure to have all the stock on hand and load it into the new tray. Or if we were using the same tray, at least have the stock, right next to the machine and count it out. And just like all these little things that typically before this, we would walk up to the machine when it stopped and go, okay, let's set up the next part. Oh, we need a new tray of stock. Let's walk across the shop and get a new tray of stock. And what you're not considering there is just that that's downtime on your machine, whether you like it or not. Right. And so this typically, he says, this step one of just distinguishing between internal setup times and external setup times, and going through meticulously sort of differentiating between things that need to happen with the machine stopped and things that can happen before the machine stops, that typically shaves 30 to 50% of setup times.
Yeah.
And that is zero cost and extremely minimal effort.
Right.
And this can be applied to machines, but again, it can be applied to all sorts of things where you have a limited resource, whether that's like, I don't know, this might be a silly example, but like a conference room, and you have a bunch of conferences, and then you have everyone walks into a conference room and starts like setting up, and where's my charger, and where is the this, and oh, let me go grab a coffee, and then the meeting starts 15-20 minutes later.
Yeah.
I don't know that you could convince everyone to be like pre-staged.
I mean, going back to our favorite example with cooking, like often having things prepared next to the stove versus like putting things in sequentially as you finish them, or into a pan as you finish them. I don't know. I've started to see examples of this everywhere. And yeah, it's been an ongoing kind of like low level push in our shop for the past, probably the past year, of starting to streamline our setups. And a lot of that actually has been the next step as well.
Yeah. So we just covered the initial phase, stage 1, which is separating internal and external setup times. And then stage 2, converting internal to external setup times. Mm-hmm. So a very world-altering example of this is the invention of shipping containers, where it used to be that ships would pull up to port, and then you'd have teams of people going down into the holds and literally hoisting stuff out with nets.
Yeah.
And it would take a long time for the ship to be at port. And now you externalize all that by standardizing the containers, so all the packing and unpacking can happen while the ship is doing other things.
Yeah.
So stage 1 can reduce 30 to 50%, but that often does not get to the target of being under 10 minutes for a setup time.
Yeah.
So it's this next stage of taking internal setups, converting things that need to happen during operation or
while the operations are stopped. Yeah.
To things that can happen before.
To give an example of this, one thing that we were kind of bumping up against is we had, because I'm cheap, we had a minimal number of tool holders. We had a minimal number of tool holders, and I was hesitant to just go buy a lot of tool holders. It seemed wasteful to me at the time.
Yeah.
But we had a scenario on almost a daily basis where a job would finish, then we would have to assess what tools were in the machine. Maybe we had the next tool, like the actual bit, end mills and drills and stuff, staged, but we would have to assess what holders we could take out of the machine to transfer tools into and what needed to stay. And that was a whole process that had to happen while the machine was stopped. So a push for us was standardizing tooling so that there's less of that questioning to do. And then B was just adding a lot of tool holders so that we could pre-stage tools so that anything that did need to get changed wasn't needing to get changed into a holder that was already in the machine. And that way it became a 5-second swap of a holder for a holder and a tool touch off instead of a potentially 3 to 5 minute swap of finding the correct tool that can be pulled, maybe doing some juggling of, this one needs to go in that slot, but we actually need the holder from that slot or that pot rather.
Yeah.
And so that has been pretty huge. And then just this last couple weeks, changing to standardized vices has been really big as well.
Very cool.
Just starting to see the fruits of that, but
yeah,
it's very cool.
We just did that recently of buying second tool holders for 2 reasons. For all of our standard machine, the tools that are used for production daily. One reason is if something breaks for whatever reason or gets damaged, not having a backup seems pretty silly. And we're talking about, a tool holder is like $120 to $190, most of ours.
Yeah.
Compared to a machine that's 1,000 times more than that. So that is the second stage, and then
converting internal to external setup.
And then stage 3 is streamlining all aspects of the setup operation. And
this is where it kind of gets into the nitty gritty.
This is sort of the launch point for the rest of the book.
Yeah.
Sort of.
And where it becomes challenging. I think the first 2 stages, even though most people don't do them, are relatively simple.
Well, I would say,
and huge gains.
Everyone out there, go from the initial to stage 1 today.
Right.
Because it's very quick and costs no money.
Yeah.
Which is non-distinguished internal and external setup times to distinguishing between the two.
Yeah.
I guess I'm actually saying go to stage 2, which is then move the ones that you've decided can be external to be external.
Mm-hmm. But I think that's sort of a multifaceted. There's things that can be moved from internal to external at zero cost.
Right.
And then there's things that require money to transition from internal to external.
You're right. Looking at this graph here, it's definitely stage 0, which is non-differentiated, to stage 1 is just about
seeing
and then making the appropriate adjustments to do everything external that can be done external in the current state.
Yeah.
And then that stage 2 is where things get a little more expensive.
Yeah.
But 2 really interesting additional points that he lays out, and I'm not sure why they're not just divided out into 5 stages, is eliminate adjustments. And this is all part of that last stage. So anytime you need to do one of the, set something, make a test cut, measure it, go again, that is an adjustment that needs to be made. And often that is done by feel or by guess and check. And that's typically because of a lack of numerical
quantification of your results.
Yeah. And so some examples he gave were on I think it was either a die casting machine or an injection molding machine. The flow through the mold, if you put too much water through it, you wouldn't get complete injection. You wouldn't get complete fill because it was cooling too fast. And then if you had too little, I forget what the issue. There were a few issues. I think one was just a long cycle time
or something.
I'm not a molder myself. But and so it was all done by feel, where people would sort of put their hand on the output hoses and guess at what it should be. And what they ended up doing is putting a thermometer in one place and then attaching a big wooden wheel to the valve control with a mark on it and putting a bigger wooden wheel behind it with increments. And then they figured out per degree change you want, rotate X number of increments.
Oh, interesting.
So
one thing that's so cool about this is these days you immediately go to I'll buy a PLC and I'll get some thermocouples.
Right.
And they're like, well, we'll just try this a couple times with a wooden wheel and make some marks. And now we know what it does because it's a stable process. We know what it does every time and we can make adjustments.
And I would say that is the last step, which is mechanization.
Yeah.
And that is taking all these basic things and mechanizing them. And he says absolutely push this off as far as possible, because what ends up 2 things. One, you're often just refining bad process in mechanizing an operation. I'm going to buy a drill to tighten all these screws instead of saying, is there a way where we can eliminate these screws? And then the second part, which is also important, is if you invest a lot of money, a powered torque wrench is I don't know, 5,000-ish, 2,000. I don't know exactly.
Not on eBay.
Not on eBay. Yeah. That's why I don't know, because I mostly look on eBay. But if you buy one of those, you're sort of bought into a particular way of doing it. And so you really want to avoid mechanization. And I think that wooden wheel is such a nice example because, as you said, like my immediate thought is, oh, PID controlled temperature, right? And that's like, $500 instead of 30 or 20 or whatever.
Yeah. Yeah.
And I think a common theme, like there's this idea of use your head, not your wallet in general, because a lot of the exercise here is not about some moral judgment of it's better to be lean.
Right.
It's actually about like cash turn. How quickly does an invested dollar in the business go back into your bank account as $1?
Yeah.
Hopefully more than $1. But
$2.15.
yeah, I mean, whatever your multiple is, but a lot of businesses have to buy materials, 6 months to a year before they're going to sell merchandise.
Yeah.
That is not uncommon.
Yeah. And for the machinists amongst us, I think we immediately think like, well, if I'm doing new parts every day, I can't, I have to prove out a part. Like that's not something you can, preset, as it were, which is what a lot of the book is about, especially in the machining examples, is like preset dimensions for a turning operation or something. And although I think that is a big lift, I think it is possible, but I think the lower hanging fruit for most of us is like thinking about like 0-point fixturing and like never resetting your origins in your machine, or doing it in a way that the machine can do it automatically with a probe in a matter of seconds instead of you taking several minutes. We had an interesting thing just yesterday where we had a prototype job, had to go onto a machine that was running production. I was very proud of myself for this example where we've now standardized vices. We've more or less standardized our coordinate systems. So we were running production. I gave Ariel the heads up. I was like, after this cycle, I'm going to jump in and do this operation on this prototype part. And so I had like jaws staged, tools staged, and like it stopped. We didn't even take the other parts and other vices out. We just pulled top jaws off, put the new ones in. We did have to cut a soft jaw, so that was like 5 minutes. And then I happened to be on the phone with you, so I was going a little bit slow. But I think overall it was about probably 20-minute changeover. In this example, I like checked what tools were being used in the current program and programmed the operations for the other ones to use empty pockets or not necessary pockets, so I didn't have to take any of the production tools out. And we were, we've now standardized our work coordinate system, so that was something I could just punch in. I didn't have to probe anything. And we were doing a prototype part within 20 minutes. They took a little while to actually do because I had to, check them and stuff. But then at the end of the day, switched right back to production. And
wow,
it's those kinds of things are super powerful. Otherwise, that could have been back in the day. That probably would have been potentially a 3-hour switch, all said and done between like all the different juggling.
Yeah, and just going from differentiated between internal and external. I think what's the easiest and most common is the machine stops.
Yeah.
And then you're like, oh, I need to use that machine for prototyping. Here's my programmed part. Oh, it's not fully programmed. On and on.
Yeah.
The funny thing for me is we've gotten now down to like a 3-ish minute changeover.
Mm-hmm.
But only if we're pretty religious about how we're meant to do it.
Mm-hmm.
It is so easy somehow and tempting to not do it properly, even though we know how to do it well. And basically what it comes down to is the machine stops. It's normally interrupting something else you're doing.
Yeah.
And so you walk over there and do it as fast as possible. And you really want to get back to this other thing you were doing. And really what you need to do is look at what's going to happen next and then pre-stage all the stuff.
Yeah.
And it's very, very easy and tempting to just walk back away from the machine and be like, let me go finish that. Then I'll come back and do this. And then inevitably it doesn't happen. Then the machine stops.
Yeah. You basically need to make the setup for the next operation be integral to the completion of the setup of the last one,
and
or the staging for the next one to be part of the setup of the last one.
Yeah, and the nice thing is it's not essential when we're not limited by our machining capacity.
Mm-hmm.
And so actually we, over the last couple weeks, have been like really pushing our capacity substantially. Things have kind of calmed down a little bit.
Yeah.
And so it's kind of nice because we learned a lot trying to do a ton of stuff and seeing what broke, because a lot of systems kind of were stressed, let's say. So now we have a little bit of like things have slowed down, so we have a little bit of room to like think about those lessons and
reassess,
figure out how to improve things.
Interesting.
But yeah, so SMED, it's a great book by Shigeo Shingo, A Revolution in Manufacturing the SMED System. Highly recommend it. Really foundational to a lot of other stuff and super applicable to non-manufacturing things. Like, it really changed the way I look at problem solving and, I don't know, life.
I mean, if most people probably are not going to read the book, but if you can just think about those as that very simple things that have to be done in the machine and things that have to be done that can be done out of the machine, or whatever your particular use case is, if it's not a machine, and just like start applying that lens everywhere, it will transform your process is.
30 to 50% reduction. And then the next step is thinking about things that currently need to happen when the internal and can be made external. And then the last is optimizing the internal stuff.
Yeah. And then a big part of this, which isn't called out as a step, but is inherent in all the steps, is eliminating things that just don't need to be done.
Yes. Yeah, absolutely.
So anytime you're setting something that could be standardized, standardize and eliminate the setting. Or if any step that you're doing that could be standardized, eliminate it.
Or you have something with 4 screws and it really only needed 2 screws.
Eliminate it.
Eliminate it. If you can eliminate, like, another example is every rotation of a screw that is not the screw coming up to clamping force or the correct torque, that's all waste. And so he has a whole, 2 pages on different ways of eliminating turning screws extra.
Mm-hmm.
Anyway, so it's pretty minute detail, but simple at the end of the day.
Makes a big difference.
Sure does.
So go do it.
Go do it.
Go do SMED.
Yeah. Awesome. Well, I think that might be a good place to leave it.
We'll jump off. You had your crash course in SMED. We expect to see results.
Something like that. Yep. Cool.
Thank you all for listening, and we'll see you in a few days.